Hi, welcome back, AP Stats students. So today, this is probably going to be our last CFU video. Woo! So it's on chapter 12.1, and this is unit 9, okay? Chapter 12.1 on inference for regression. So concept 1, the sampling distribution of slope, right? So we are trying to understand the sampling distribution, what goes on there when we're trying to sample slopes. And concept 2 is to be able to do confidence intervals for slope, right? So to check for understanding, students will be able to construct and interpret a confidence interval for the slope beta 1 of the population, right, which is the true regression line. So let's dive in. A study by Consumer Reports rated 10 randomly selected cereals on a 100-point scale. Higher numbers are better, and recorded the number of grams of sugar in each serving. The data from the study are shown below. So you have the sugar and then you have the rating. And as you can see, the LSRL, the least square regression line for this data is given as, so the predicted R value, right? R, assuming R is the rating, where R is the rating. So the predicted rating is equals to 82.62 minus 4.77 times S, where S is the sugar. So construct and interpret a 95% confidence interval for the true slope of the regression line. Assume the conditions for performing inference are met. So in this case, the inference, the conditions will be the liner, L-I-N-E-R. So all those conditions are met. Now, before I go on and before we go through the construction of the confidence interval, put the sugar into list 1 and put the rating into list 2. Because here, list 1 is typically your explanatory data, right? Your explanatory variable. In this case, it's the sugar. And rating, you put it in list 2, which is your response variable. And so if you look at, there's a way to calculate the least square regression line. And I'm going to just review it with you quickly. So if you look at my calculator, you should be able to see that I've already put into list 1 the sugar point scale, right? The sugar, the sugar in grams. And list 2, which is the response variable and indicating the rating, right, out of a 100-point scale. So I'm going to show you now how to use the calculator to find the least square regression line. So here, you put into list 1 and list 2. And then you go to stat, and then you go to calc, right? So sometimes people use 4. You see that it's linear regression. Number 4 says LIN, lean reg. It's AX plus B. Stats teachers or students tend to use number 8, which is also the linear regression line, right? But it's in A plus BX form. So here our X list is L1, Y list is L2, and everything is as per normal. Voila. So you see that the A indicated here is 82.62, and if you round this A to 82.62 to 2 decimal places, in fact, that's the case. And then the slope, it's negative 4.77, indicated here, 4.77. All right, 4.77. So, but it's interesting enough that typically the R and the R square shows up here. And if it doesn't, that means you haven't turned on your stat diagnostic. So go to mode. And then if you scroll down to, you see the the third from the bottom. Now it may be different from your calculator. It says stat diagnostic. You want to turn it on. Now after you turn it on, you can quit, not second quit, and then if you do the test again, right? If you not test, if you do the linear regression again, or number 8. Notice that the R and R squared, the correlation coefficient actually shows up here. So it's a negative relationship. Okay, that's cool. All right. Okay, so to begin this confidence interval construction, we try to state. So we say we want to estimate the true slope. Now the true slope has a symbol, just like true mean, right? Population mean is mu. Population proportion is p. Population standard deviation is sigma. Those kind of things. So true slope has a symbol. It's beta, right? It's beta. So so we want to estimate the true slope of the population regression line relating. Now this is where you state your explanatory variable, which is the number of grams of sugar, to relating it to what? To your response variable, which is the rating of the cereals. Okay, so next is the plan part. So here, we were already told in the question that the conditions for performing inference are met. So, and the conditions are, there are 5 conditions, right? And the acronym for it is LINER. So it's linear, independence, normality, and equivariance, and random. So all the conditions are met. So we will use a t interval for the slope to estimate beta, right? The true slope of the population regression line. Okay, so the do part here, so we will use the t distribution with, right, the degrees of freedom is actually going to be, n minus 2. So here our sample size is 10. So 10 minus 2 is 8. So the degrees of freedom is 8. Now we need this to calculate or to find critical value. Now you might ask, what is critical value? The critical value actually is your T star, right? It's your T star that that you need for to when you do when you try to calculate by hand the confidence interval for the true slope. So here B, that's your unbiased estimator, right? That's the B that we found earlier, and that actually is right here, the negative 4.77. And here T star, right? T star is what we need to find, and you have to use the degrees of freedom to find that. And I will show you in a second how to find that. Now here, the SEB, which is the standard error of the slope, right? The standard error of the slope, which we will discuss in a second. All right, okay. All right, so let's continue, right? So for a 95% confidence level, the critical value T star. Now we need T star. Sorry for the interruption. So T star is inverse T, and we need the area, right? We need two things, 2 parameters, the area and the degrees of freedom. So since this is a 95% confidence interval, remember that inverse T, you are adding, area to the, so here if this is 95, so 0.95, and here is 0.025, because it should add up to those two tail here and here should add up to 0.05. And inverse T takes this area here, right? Because you want to find this T star, right? This T star value. So we need to add this and this together, which is 0.975, right? Actually, I need to. So it's 0.975, and the degrees of freedom is 8. And if you go to the calculator, I hope you remember how to get there. So perhaps I can show you very quickly. 0.975 degrees freedom of 8. So if you go to second verse, you see in verse T, number 4. So if you can go straight to 4 and ask you for the area 0.975, and the degrees of freedom is 8 because it's 10 minus 2, right? Sample size minus 2. And that should give you 2.306. 2.306. So let's get back to our original screen here. So here is 2.306. All right, so let me perhaps clear this bunch. Okay, let's see. Okay, it should be gone. And let's continue. So now the formula for this slope interval, this confidence interval to estimate the true slope is B, which is the slope, the point estimate, right? Plus minus T star times standard error of the slope. Now we know the B already. The B was, already found here, negative 4.77. And we just found the T star, which is 2.306. So how in the world are we supposed to find standard error of the slope? Now, standard error of the slope has this really wicked formula, S, which is the standard deviation of the residual, divided by S of x, which is the standard deviation of the x variable, right? Then further divide by square root of m minus 1. Now, it's pretty tedious to go through that to find standard error of beta, right? Standard error of the slope. So there is a shortcut, right? I'm just going to go through quickly. Shortcut to find, there's a way to cheat, to find the standard error of the slope, right? If it's not given. Sometimes it's given to you and sometimes you have to find it from the computer output. But if it's not given, this is the way to cheat. So if you go to stat, go to test, go to F. This is a new test now. It's linear regression t-test. And if you put down your X list as your L1, Y list as your L2, and then you click the next step is not equals to 0. And then you pick out the T, which is negative 4.723558.597, and then you scroll down further to pick out the B, and B in that case is negative 4.77, which we already know. And then you use this formula, B divided by T, right? B divided by T will give you the standard error of the slope, which is 1.0105. So let me just show you very quickly how do we do it. Now we go to stat, then we go to test, and then perhaps scroll up will be quicker. So if you scroll up, you see F, right? Linear regression t-test. So here, L1, L2, and we choose not equals to, right? Not equals to, and then we go to calculate. Now, why is it not equals to? I need to explain. So if it's more than or less than, is a one-tailed test. So here we are looking at 95% confidence interval. So we are looking at a two-tailed test. So that's why we chose, not equals to 0. As you can see now, the third line down. Do you see? T equals to negative 4.723558.597. And then if you go down further, in this case you do not need to scroll down. If you go down further, on the second line from the bottom, you see B equals to negative 4.7731666667. If you do B divided by T, and that will give you the standard error, right? B divided by T, that will give you the standard error of the slope. In this case, is 1.0105. All right, so to finish the do part, so we do a 95% confidence interval for the true slope, and the formula follows, right? B plus minus T star times the standard error of slope. So we put all the values together, right? So we know B is negative 4.77 plus minus the T star is 2.306, and the standard error of B, which we cheated and we found to be 1.0105. So all this is when you're doing by hand, right? So, and you found the confidence interval to be between negative, well, let's pause this, negative 7.1 to negative 2.440. Right. So now you, as you suspect, there is going to be a calculator function for this t interval for slope. So how do you do it? You go to stat, you go to test, and then you go to G, not F, you go to G, linear regression t interval, right? G. And then the X list, you have L1, the Y list, you have L2, and then you proceed to frequency is 1, just leave that. Confidence level is 0.95. The regression equation, leave it blank, and then you calculate, and you will get this t interval for the slope. So let's kind of do it on the calculator. So let's clear this. So if you go to stat, if you go to calc, and if you scroll up, you see G is linear regression t interval. And then it asks you for X list, which is L1, Y list L2, frequency 1, leave it, confidence level 0.95, and leave that blank, the regression equation, and then calculate. And you will see, voila, look at that, pretty. So the confidence interval is negative 7.103 to negative 2.443. And do you see that B here is your slope, which we found earlier, negative 4.773, and then degrees of freedom is 8. The one here, you see S is the standard deviation. And A, which is your y-intercept, 82.61. And then they even throw in the R square and the R. How nice. All right. Yeah, there's nothing there. Okay. So, all right. So let's resume. Okay, so I need to conclude. Right, so let's pause. So to conclude, ladies and gentlemen, we are 95% confident that the interval from negative 7.100 to negative 2.440 captures, or you can say contains, the true slope of the regression line, right? So let's go to the next question. Thank you. Hi, this is the last a continuation of chapter 12.1. CFU for inference for regression. Concept 3 on the significance test for population slope. To check for understanding, students will be able to interpret the values of B naught, which is the y-intercept, and B1, which is the slope. S, that's the standard deviation of the residual, and SEB, which is the standard error, standard deviation, right, of the slope. So in context, and determine these values from the computer output. So what you see here, right, is the computer output. right here you see this is a kind of a computer output where you can actually read those values for certain parameters, right, or certain statistics, and we'll go through that. And second, check for understanding is students will perform a significance test about the slope, right, the population slope, which is also called the population true regression line. All right. Okay, so this is as far as it goes. So let's take a look at, we don't really need the, so right here on the left hand side, the graph, you see that's a scatter plot, right? And the sugar content is your explanatory variable, and your ratings, your y-axis, right? That's your response variable. And then over to the right, you have the residual plot, okay? The residual plot. Residual is actual y data minus predicted y data, all right? So I'm going to show a little bit of the computer output, and let's work on this one. The study in the previous CFU was expanded to include a total of 77 randomly selected zeros. The scatter plot, residual plot, and the computer output of the regression analysis are noted above. So use this output to determine the least square regression line for the sample data. Okay, so question number one, use this computer output to determine the least square regression line for the sample data. Now, we need to first identify what's our x and what's our y, right? X is our explanatory variable. In this case, it's the sugar. So if you look at the sugar row, those values are all, associated with the explanatory variable, the sugar. And the row above, right, will it's associated with the y, right, the y variable. In this case, the y variable is the rating. So now, how do we read the computer output? So the A, right, is your 59.284, and this A refers to your y-intercept. And then B, right, on the bottom, the second row, is your slope. So your slope is negative 2.4008. So it's a negative slope. So the least square regression line. Now, typically we write y hat, right? Y with the inverted, like a caret thing. Y hat is also known as predicted y value. Now, it's equals to the A plus bx, right? Because line of best fit, you have mx plus b, right? Remember the line of a straight line, the equation of a straight line. The formula is mx plus b. M is your slope and b is your y-intercept. But in this case, in stats, we like to write a plus bx. A in this case is your y-intercept, b is your slope. So, right, a is your y-intercept, b is your slope. So to write out this actual least square regression line, we need our y. Our y in this case is the rating, right? The rating score. And we got to put a hat on it, right? Put an inverted V. Equals to the A, the y-intercept from the computer output is 59.284. Plus, then we put a negative 2.4008, that is your slope, multiplied by your x variable, right? In this case, our x variable, explanatory variable, is the sugar. Okay, and so just wanted to explain again the inverted V, that hat symbol, all right? It means predicted rating score, right? Right, so question 2, interpret the slope in the context of the situation. So what is the slope? From the computer output, the slope was determined to be negative 2.4008. So it's a, decrease, right? Which also mean that this rise over run slope is actually rise over run. Now, if it's negative, right? If it's negative, that means for every increase in the x-axis, right? For every 1 unit increase in the x-axis, there will be a decrease in the y-axis. So that's how you need to, try to reason to put the slope in context. So for each increase of 1 gram of sugar, because sugar is our explanatory variable, right? It's on the x-axis. For each increase of 1 gram of sugar, we estimate, or we say predict, that there is an approximately, so what's the value here? 2.4008 point decrease in the rating score. So part 3 is there convincing evidence that the slope of the true regression line is less than 0. So this is where we do our hypothesis test, right? Testing significance tests for the true population slope. So state, we will perform a t-test. Right? Why is this a t-test? Because we are looking at quantitative data, right? And we do not know the standard deviation of the population, so we use a t-distribution. So we are using a t-test for the slope of the true regression line, okay? So H naught is, that's the symbol, beta. That's the symbol for the true population slope. And null hypothesis, we always let the null hypothesis says that there's no difference. So in this case, we are saying that it is 0, right? There's no slope. Our alternate hypothesis is that the slope, the true slope, population slope, is less than 0. Okay, so let's continue. The next step is plan. And this is where we try to look for the conditions. So in this case, for the inference for regression, there are not just 3 conditions, there are 5 actually. And it fits the acronym LINER, L-I-N-E-R, right? L stands for linear, I stands for independent, N stands for normality, E stands for equal variance. Now this is new, right? This is something that I don't think you know, or you can that you remember, or you can just come out from thin air. So there's something that you have to remember, right? Equal variance and random, and you know this. So the LINER, right? The acronym stands for all these 5 things. So the zeros are randomly selected and they are independent from each other. So that satisfies the random condition, it satisfies the independent condition. Next thing, the scatter plot, right? The scatter plot is useful because in this case it suggests a negative linear relationship. So is it linear? Yes. Even though it's a negative one, it's linear. So that satisfies the linear condition. So 3 out of the 5 now. Now, the next one is that you got to use the scatter plot. Sorry, you got to use the residual plot, right, which is provided. The residual plot does not display a distinct pattern. And if you, just a bit of recap, review, if the residual plot doesn't display any visibly visible pattern, it means that the linear model that we have used for this particular scatter plot, for this particular relationship between the predicted rating scores and the sugar content, the linear model is actually a good one. Right? It's a good fit. So anyway, this is review for chapter 3. But in this case, the residual plot has a lot to do with satisfying the equivariance condition, because the equivariance condition, you have to look at the residual, and equal, that means you look at the like y equals to 0, and if you look at that line, there is equal number of points that are above the y equals to 0 as well as below y equals to 0. So here that's what we use the residual plot for, all right, to satisfy the equivariance condition. So it says the residual plot does not display a distinct pattern. However, some students might argue that, hey, the residual do appear to be slightly smaller for larger sugar content. You can put it down and there's nothing wrong, all right? So the one condition here that is really iffy, and that's it's testing for the normality condition. To test for normality, right, to say that the data collected is normal or approximately normal, we need a few things. We need the normal probability plot, which is not given in this case. But if the normal probability plot, if it shows a linear pattern, then you can say that the data is approximately normal. Or you can look at the histogram. If it's like a single peak and symmetric, you can say that it's roughly normal. Or you can look at the... Oh, let me resume. You can look at the box plot. You can just look at the pattern of the data, right, to see if, you know, a histogram, dot plot, just to see if it's, you know, if it suggests a normality pattern where it's bell-shaped, single peak is symmetric. Okay. Okay, so the next step is the do step. Now, when you're given a computer output, it is so easy to read the t-statistics and the p-value from the computer output. All you have to do is read the second row. All right, so according to the computer output, right, the t-statistics is negative 10.12 and the p-value is approximately 0. You see the big T and the big P on the computer output? They represent, they stand for t-statistics and P stands for p-value. And you have to read the second row, right? So, and now we conclude. Now, since the p-value, which is very, very small, right, close to 0, negligible, is less than 0.05, we reject H naught. All right, we have convincing evidence to suggest that the true slope of the true regression line is less than 0. So hopefully this doesn't come foreign to you, because we have been doing 4-step process, we've been doing significance testing. The only difference here is that we are reading the computer output if it's given to you, and the conditions, there are a little bit more, a couple more conditions that you have to check. So other than that, the same procedure. So hopefully this makes sense, and if you have any questions, please let me know. Thank you very much. Bye.